Let's talk about degree measure. Degrees are probably the most widely known and used measure of angles. You notice the symbol. A measure of 1 degree is equivalent to a rotation of 1/360th of a complete revolution about the vertex. So a full revolution corresponds to 360. A quarter revolution is 90, and so forth. Notice the correspondence between degrees and radians. We're going to use that in the next slide. From the equations, we have that 1 degree is pi over 180 radians, and 1 radian is 180 over pi degrees. So to convert degrees to radians, multiply degrees by pi over 180. To convert radians to degrees, multiply by 180 over pi. To apply these two conversion rules, use this basic relationship. Pi radians is 180 degrees. Okay, these conversions can be combined into one formula. 180 radians equals pi times degrees, where r is radians, d is degrees. If r is known, for example, substitute r in the equation and solve for d. Notice that there is no symbol used for radians. When angle measure does not have a symbol, the unit is radians. Let's do some actual examples. Okay, let's start by converting degrees to radians. This is what we will have to do probably more than the other way around. So suppose I have 60 degrees. I'm going to notice the formula 60 over 180 equals r over pi. Cross multiply 60 pi equals 180 over r, and so forth. Do the appropriate division, and we have that 60 degrees is pi over 3 radians. Let's try 125 degrees. 125 over 180 equals r over pi. Again, cross multiply. 125 pi equals 180 r. Solve for r and reduce the fraction, and so r will be 25 pi over 36 radians. Let's suppose the degree is 34 degrees. Okay, 34 over 180 is equal to r over pi. Notice that sometimes we use a decimal approximation for pi to make a more meaningful angle in radians. So solving for r is 0.5934 radians. Now, next, let's convert radians to degrees. All right, so suppose we have pi over 3 radians. So we'll say pi over 3 is to pi as d is to 180. Implies that d over 180 equals 1 over 3. Do your arithmetic here. So 3d is 180, d is 60 degrees. Suppose r is pi over 5. Then pi over 5 divided by pi is 180, d over 180, sorry. And so cancel out the pi. D over 180 is 1/5, so 5d is 180, and we've got 36 degrees for a radians of pi over 5. Now, let's suppose that our radians are given as a decimal. This is where you will use pi as a decimal, and you'll get out your calculator to do the multiplying and solving for d. Notice I said here degrees to radians will be used a lot more than radians to degrees. We will discuss this later. It's very important to learn the following equivalences. They will be used extensively, and you need to be able to do it. No time to do any kind of computations. Measure them. Pi over 2 radians is 90 degrees. Don't ever have to think about it. Notice the equivalence is in the degrees diagram below. You notice we've got 30 in pi over 6, 45 in pi over 4, 180 in pi, 360. Again, these must be learned. Trigonometry does a lot of work with degrees, but other courses will use radians extensively.